Here is a rectangle and a right angle triangle. All the measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. We need to find the set of possible values that x can be. So the area of the rectangle I can find by multiplying these two lengths together. So I've got the 3x minus 2 multiplied by x minus 1. I can expand those brackets out. So you can use the grid method if you like, or we can just do 3x times x is 3x squared. 3x times minus 1 is a minus 3x. Minus 2 times x is minus 2x. And then the minus 2x times minus 1 is a plus 2. And then we can collect up these like terms. So that is the area of that rectangle. The area of the triangle, half base times height, so half 6 times 10, is 30. And we were told that the area of the rectangle was greater than the area of the triangle. So this is greater than 30. Right, so we have a quadratic inequality. So I'm going to subtract 30 from both sides to make this greater than 0. And then I'm going to factorise this so I can find the roots. So I know it's going to need to be a 3x and an x. I know 3x times x gives me a 3x squared. Now I'm looking for numbers that are going to multiply to make minus 28. I'm thinking probably a 4 and a 7, and one of them is going to need to be a negative. Maybe I'm wrong, maybe it needs to be a 14 and a 2, or maybe even a 1 and 28, but I always like to try the numbers that are closest together first. So I'm going to try 4 and 7. So if I had that as a, let's have that as a 4 and that as a minus 7. Let's see if that works. Does that give me the minus 5x? That gives me minus 21x. And a 4x would be minus 17x. So no, that definitely doesn't work. So what about if it was the other way around? Maybe if that was a plus 7 and that was a minus 4. Does that work? So that would give me a minus 12x plus 7x minus 12x plus 7x minus 12. Yes, that does work. That does give me the minus 5x. So there we go. I have managed to factorise that now. So I know the roots are at 4 or minus 7 over 3. So those are my two roots. In order to solve this inequality though, I'm just going to draw a very quick sketch of this quadratic. The roots are at 4, which is over here, or minus 7 over 3, which is roughly there. So my quadratic would look like that. When is my quadratic greater than 0? Over here. And over here is when it's greater than 0. So this region here is the bit where x is greater than 4. This region here is where x is less than minus 7 over 3. Now, it doesn't make any sense in the context of this question to have x as a negative value. Remember, we're talking about the lengths of a rectangle here, so it wouldn't make any sense for x to be less than minus 7 over 3. So x is greater than 4 is my solution to this question.